Okay, this is page 169. And the title is Function Operations. Function operations. So basically what I'm going to teach you how to do today is add functions, subtract functions, multiply functions, divide functions, and it's actually pretty easy. So hopefully you'll think the same thing. So the first thing we're going to do, we're going to talk about adding and subtracting functions. So we are going to let f of x equal 4x plus 7. And we are going to let g of x equal the square root of x. And then I've got another plus x that is not under the radical sign. And a lot of times when you work with function operations, you're going to be asked to find the domain or range. And so if we look at function f, remember domain is all possible x values. So domain, all possible x values. Is there any real number that if I plugged it in for x, if I substituted it for x, could I not multiply by 4 and add 7 and get a real number? Any number that I couldn't substitute in? No. So what do you think my domain would be? All real numbers. Remember, you can write it with that little fancy double R looking thing. How about your domain of G? Now we're talking about real numbers only. Is there anything that I substituted in for either of these x's and simplified that I would not get a real number?
A negative number.
Right. I can't plug in a negative number, right? But can I substitute a 0? 1, 2, 3. If I substitute a -1, what's the square root of -1? It's an imaginary number, right? And if we're just talking about real numbers, then you cannot substitute in a negative number. Not because of this x. I could substitute anything in for this x and it's fine. But because of that radical, if it's a negative, it's not going to work. So for the domain of G, I would put all real numbers greater than or equal to 0. Or you could put y is greater than or equal to 0. That's fine too. Okay, so we haven't actually gotten a question yet. The question says, what is f plus g? That means the same thing as what is f of x plus g of x. Okay, sometimes they just write it as f plus g. Sometimes it'll say f of x plus g of x, but they mean the same thing. So all you do is substitute whatever function f is equal to, 4x plus 7, added to whatever function g is equal to. And since I'm adding, I don't need parentheses. If you put them, that's fine, but you don't need them. I'm not solving for x. I am just adding them together. Do I have any like terms? 4x and x. Is that this square root of x? Does that also go with that? No. So what's 4x plus x? 5x. Can I add anything to the square root of x? No. Can I add anything to the 7? Nope. And that's it. So we said what the domain of f was and what the domain of g was, but what is the domain? Of f plus g. So basically, when you got your final answer, what's the domain going to be? Is it going to be all real numbers? Greater than or equal to 0, right? Because we have that radical still. So domain will be all real numbers greater than or equal to 0. Or you could say y is greater than or equal to 0. Everybody cool with that? Okay, now we're going to subtract them. So if it says f minus g, or it might say f minus g of x, and I didn't write that one above, but it could have said f plus g of x. Or if it says f of x minus g of x, it all means the same thing. Function f minus function g, no matter which way it's written. So we're using the same function f and function g as we had above. So function f was 4x plus 7 minus function g. G is 2 terms, so it is imperative that we use parentheses because we're going to have to distribute that negative. And by the way, we're still using the same function, so the domain of f is still all real numbers. The domain of g is all real numbers greater than or equal to 0. Since we're using the same functions, we don't need to rewrite it. Okay? So first thing we're going to do is distribute the negative. So that gives us 4x plus 7. And that would be minus the square root of x minus x. So very similar to when we added them, except for the signs changed in function g. So now we have 4x minus x gives me what? 3x. And then I have nothing else to combine, so minus the square root of x plus 7. So when I subtract f minus g, what's my domain? All real numbers greater than or equal to 0. Not so terrible so far, right? Pretty easy. You may have a question? Okay, page 170. We're going to change function f and function g. This time, let's let f of x equal 4x minus 1 and g of x equal 2x squared plus 3. And what's my domain of f? All real numbers. Good. What's my domain of g? Also all real numbers. Exactly. Because I could substitute anything in for x, any real number, square it, and multiply by 2 and add 3, and I'm going to get a real number, right? So they're both all real numbers on that one. So my first question is to find, sometimes you're going to see it written like this, f plus g, and then of x outside of it. I don't know why they have to write it in so many different ways, but they do. So no matter how you see it, you'll know that that just means f of x plus g of x. Function f plus function g. So this time we're just adding them together, so you can put parentheses if you want, but they're not necessary. So function f is 4x minus 1 plus function g is 2x squared plus 3. We're not solving for x. We don't have to factor. All we have to do is combine like terms and put it in standard form. So what term would I be writing first? 2x squared. Does it have any like terms to combine it with? No. So 2x squared plus 3. Oops. Did not mean to write plus 3. Sorry about that. Just 2x squared. My next highest degree is linear, 4x. Does it have any like terms? No. So just write plus 4x. And then I do have two constants. Remember, constants don't have any degrees. So we'll combine those. Negative 1 plus 3 gives me plus 2. So what's my domain of f of x plus g of x? All real numbers. There's not any real number that I could substitute in for x that I would not be able to simplify. Remember, another way you could say all real numbers is literally all real numbers. Or you could write it as negative infinity to positive infinity. Interval notation, you could do that also. It means the same thing. All right, so let's subtract. We're using the same function f and function g as at the top of the paper. This time we will find g minus f of x. Means the same thing as g of x minus f of x. This time they're starting with function g though. Last time they started with a function f. So function g is 2x squared plus 3. Subtracting, since function f has two terms, it's going to be important that I use parentheses so that I can distribute the negative to both terms, not just to the 4x. Everybody okay with that? So first thing I'm going to do is distribute the negative. So I get 2x squared plus 3. Negative times positive 4x is negative 4x. Negative times negative 1 is positive 1. Combine like terms. My highest degree is 2, the quadratic term. There's nothing to combine it with, so 2x squared. My next highest degree is 1 for this linear term. No like term, so I'll just bring it down. And then I do have two constants like I did before. Positive 3 and positive 1 make positive 4. What's my domain there? All real numbers. So that's just adding and subtracting. Now let's talk about multiplying and dividing functions. And I only have like 4 questions left, 4 problems. Anybody have a question on this? All right, 171. So multiplying and dividing functions. Function f, this is the same function as on the previous page, but since it's on a new page, I'm just going to rewrite it. So let function f of x equal 4x minus 1 and g of x equal 2x squared plus 3. And we already said what their domain was on the previous page, so we're not going to restate that. And I am going to find f, and they'll write it with that little multiplication dot, meaning multiply, f times g of x. which is the same thing as f of x times g of x. Taking function f and multiplying it by function g. This time we have two terms on each. They're both binomials. I'm multiplying them. So a binomial times a binomial, I'm going to have to put parentheses around both functions. And I will have to distribute to get rid of the parentheses, which we have done in this class probably 1,000,000 times. Now we're multiplying when we distribute, so you have to remember your exponent rules, all right, and your multiplication when you have exponents. So first thing I'm going to do, I'm going to multiply 4x times both terms in the second set of parentheses. So what is 4x times 2x squared? Nice. 8x cubed. Multiply the coefficients. X times x squared, keep the base, add the exponents. All right, what is 4x times positive 3? But it's not squared, yeah, because I only have one x here. The 3 doesn't have an x, right? So now I'm going to take and I'm going to distribute the -1 to both terms in the second set of parentheses. So -1 times positive 2x squared, negative 2x squared, and -1 times positive 3, -3. Now, do I have any like terms to combine? No, but is it in standard form? No, so we can put it in standard form. Our highest degree is 3, so 8x cubed will still come first. Our next highest degree is 2, the quadratic term. Next highest degree is 1, our linear term. Constants always go last. They have 0 degrees. So we've got a cubic polynomial with 4 terms. We're not solving for x. We're just simplifying. What would my domain be? All real numbers. So now we're going to divide. Same function f, same function g. So you might see it like g divided by f in parentheses, and then a little x out beside it. That means g of x divided by f of x. So function g is 2x squared plus 3 function f is 4x minus 1. If you can factor either the numerator or the denominator, you have to, okay? You don't just write them and then be done with it. If you can factor them, you have to, because any like factors you have to cancel. Okay, so in this case, can I factor 2x squared plus 3? Well, it doesn't have a GCF, right? Let me just double check. A would equal 2. What is B? 0. C is 3. See, we need two numbers that multiply together to give you A times C, which is positive 6, and add to get B, which is 0. 6 times 1 is 6. 6 plus 1 is 7. Even if you change it to negatives, it won't give you 0, right? 3 times 2 is 6. 3 plus 2 is 5. And even if you change those both to negatives, it still wouldn't give you a 0. So that's not factorable. Is 4x minus 1 factorable? No. So factor, numerator, I'm going to put slash denominator where possible. In this example, nothing can be factored. So can I reduce 2 and 4? I mean, I want to, can I? No. If I have a binomial, if it was just 2x squared divided by 4x, I could reduce 2 and 4. I could reduce the x squared and the x. Because a monomial divided by a monomial, you can just reduce parts of it. Though remember, if you have a binomial, if you have to put parentheses around it to help you remember, it's all or nothing. 2x squared plus 3 can only be reduced with 2x squared plus 3. 4x minus 1 can only be reduced with 4x minus 1. Okay? If it was just a monomial divided by a monomial, that's one term. That's when you can just reduce pieces of it. Y'all remember that? But a binomial and a binomial, it's all or nothing. You can't just reduce pieces. Okay. So that's all I can do. What do you think the domain is? We want to say all real numbers, but don't we have a variable in the denominator? So there's going to be some number that if x equaled that number, it would give me a 0 in the denominator. And you can't have a 0 in the denominator, can you? It's going to be all real numbers except, what would I plug in for x or substitute in for x that would turn the denominator into a 0? Well, 4 times 0 is 0, but 0 minus 1 is negative 1. So 4 times 1 is 4. 4 minus 1 is 3.
0.25.
0.25. What is it as a fraction? 1/4, right? Or 0.25 is the same thing. Now, if that was just x minus 1, what would it be? 1. That's easy. But when you have that coefficient of x, all you have to do if you're not sure, just take that denominator. Remember how we found restrictions? You're just finding the restriction. Set it equal to 0. Solve for x. And that's your restriction. That means that's what your denominator can't be. Your x in the denominator, so x is a domain. Everything, x can be anything that you want it to be except for 1/4, because that's going to give you a 0. I could have done the double R too. Yeah, can you keep your head up so you don't have to catch up when I'm ready to turn the page, please? Does that make sense? And the numerator, there's nothing about that. I could substitute in any number for x in the numerator, square it, multiply by 2, add 3, and would give me a real number. Two more examples, and then it's almost spring break. Talking to fourth period only. Everyone else will do this after spring break. Okay, page 172. New functions. Let f of x equal 3x squared minus 11x minus 4 and g of x equal 3x plus 1.
Wait, back to the other one.
That's all there was. If you can factor it, you factor and reduce anything that you can. But if it's not factorable and there's nothing to reduce, then that's all. That's it. We're not solving at all. We're just simplifying, no solving. So in this one, the domain of f is what? All real numbers. any real number I substitute in for x, I can simplify and get a real number. How about the domain of G? All real numbers. You're getting really good at this domain stuff. So my question is, what is f times g of x, which y'all know that means f of x times g of x. What is function f times function g? It looks crazy the way it's written at first, kind of confusing, but that's all it means. So I am multiplying, this time I'm multiplying a trinomial times a binomial, definitely going to need parentheses. So function f times function g. There's going to be a lot of distributing, so you want to make sure that you keep yourself in order so that you don't confuse yourself or leave something out. So every term in the first set of parentheses, I have to distribute to every term in the second set of parentheses. So I'll just start. What is 3x squared times 3x? 9x cubed. What is 3x squared times positive 1? 3x squared, and that's plus, right? Okay, now we'll move on to the negative 11x. Negative 11x times positive 3x. Good, negative 33x squared. And negative 11x times positive 1. Negative 11x. We're not finished yet, though, because we have to distribute the negative 4 times both terms. So negative 4 times 3x. Negative 12x. And negative 4 times positive 1. Negative 4. All we have to do is combine like terms, and that's it. So my highest degree is 3. I only have one term with 3 degrees, so there's nothing to combine it with. My next highest degree is 2, which is a quadratic. What's positive 3x squared minus 33x squared? Negative 30x squared. And then we have negative 11x minus 12x. Good. And only one constant. Constant always goes at the end. That's all. We're not solving for x. We're not graphing. We're not doing anything. We are going to say, what is the domain of f times g? All real numbers. One more problem. We're using the same function f and the same function g. Does anybody have questions about this one? All right, this example, we are taking function f and dividing by function g. So you may see it written like this, but we know that means f of x divided by g of x. Function f's in my numerator. It is 3x squared minus 11x minus 4. Divided by function g is 3x plus 1. When you're dividing, you want to factor where you can, because if you have any like factors, same on the numerator in the numerator as the denominator, you're going to cancel them out. Okay? So can we factor the denominator? No, that's not factorable. But the numerator, well, the denominator is linear, so the only way you can factor a linear expression is if it has a GCF. There's not one, so there's nothing we can do. The numerator is a quadratic, so it might be factorable. We need to check it out, okay? So we know we can't factor the denominator. We don't know if we can factor the numerator until we make our little t-chart and see if we can find numbers that work. You already that fast thing. Well, what's A? 3, B, and C, -4. Make a little t-chart. We need two numbers that multiply together to give us AC, which is -12. Add to get B, which is -11. What'd you say it was? -1 and negative.
No,
-1 times +12.
No, it's -12 and
no, it's not. Because when you add it,
Well, let's see. -1 times 12 is -12. -1 plus 12, yeah, that's going to give me a +11. So we need a +1 and a -12. Gives me -12. And 1 plus -12 is -11. So a +1 and a -12. Sorry, that's down in the corner. So in my parentheses, I have x plus 1 and x minus 12. Are those my factors? What have I not done? The old divide and slide. And since A is some number other than 1, I have to do it. Otherwise, it's going to be wrong. So I'm going to divide or I'm going to slide by 3. So 1/3, is that going to be a divide or a slide? A slide. Remember, if it's a slide and you can reduce, you must reduce first. Can you reduce 1/3? No. So slide it on over. And what's my new factor? 3x plus 1. X minus 12/3, divide or slide? Divide, because it, bless you, because it divides evenly. What's my new factor? X minus 4. Okay? Quick check, first term times first term gives me my first term. Last term times last term gives me my last term. So I did not completely check it, but if I at least do a quick check, I can probably know that it's correct. I'd have to do the whole thing to know for sure. So my numerator was factored to 3x plus 1 and x minus 4. My denominator can't be factored, so we just leave it as 3x plus 1. Can I cancel any factors? 3x plus 1. But before you do that, since this is in the denominator, when I say what my domain is, excuse me. Okay, before you cancel those out, think about your domain, because this will give you a restriction. Even though it's going to cancel, you have to consider it when you're considering your domain. So domain is going to be all real numbers except what? And it won't be 1/3, it will be -1/3. If you set that equal to 0, you would subtract 1, divide by 3, that'd give you -1/3, right? But for my answer, you're going to cancel any like factors, and whatever is left is your answer. I can't go back. It's the same person. Y'all get all that? Okay, that's the last one. I'm going to stop the recording and then go deliver this message.